measurements and units form the essential framework of scientific investigation and engineering applications. Let's begin with measurements. Measurements provide the fundamental data that form the basis for hypotheses, theories, and laws that describe the behavior of matter and energy. Every scientific measurement carries three essential elements: a number, which tells us the size or magnitude of what we observe, a unit, which gives us a standard of comparison, and an uncertainty, a subtle acknowledgement that no measurement is ever perfectly exact. Measurements can be expressed in decimal form or scientific notation, which is also known as exponential notation. For example, the distance from Earth to the Moon is about 3.84 times 10 to the 5th kilometers, while Avogadro's number, which represents the number of particles in 1 mole of a substance, is roughly 6.02 times 10 to the 23rd power. Writing these values in scientific notation allows scientists to express enormous and tiny quantities with equal clarity. Every observation in science relies on quantifying the world around us. When Perseverance analyzes a rock, it's measurements that turn raw data into meaningful information. But measurements alone aren't enough. We need units, standardized references that allow scientists across the globe, or millions of miles away, to communicate and compare results accurately. Consistent units prevent costly mistakes, such as the one that led to the loss of the Mars Climate Orbiter because one engineering team used imperial units while another used metric units. To prevent confusion, scientists around the world follow a unified standard known as the International System of Units, or SI units. The SI system ensures that every laboratory, whether in Paris or Tokyo, speaks the same quantitative language. It defines base units, the meter for length, the kilogram for mass, the second for time, the Kelvin for temperature, the ampere for electric current, the mole for amount of substance, and the candela for luminous intensity. All other units, like newtons, joules, and pascals, are derived from these base units. Sometimes the quantities we measure are either too large or too small to conveniently express using only base units. In such cases, prefixes are introduced to multiply or divide the base unit by powers of 10. For instance, a kilometer represents 1,000 meters, while a millimeter is 1,000th of a meter.